Good morning. Today is Tuesday, December 11th, 2020, and our I Can says, I can find lines of symmetry in shapes and objects. We are going to be using your green book, Module 4, on page 91 in just a minute. So if you need to get your green book, go ahead and do that. It's page 91. I'm going to start with a couple notes that I want to clarify from yesterday. So we started drawing some shapes in our notebook, and these are the shapes that we're trying to remember. So we're going to draw a couple of them again and see if we can remember what we learned about them. Let's start with our square. I'm going to start by drawing a square. And I know that a square is special because a square has 4 equal sides. That makes it different than a rectangle. So a square, I'm going to put it below it today. Yeah, that looks like a square. My square has 4 equal sides. That means that this side equals this side equals this side equals this side. And my square also has 4 equal angles. This angle makes a 90-degree angle. So does this one. It's another right angle. Here's a right angle, and there's a right angle. So we have 4 equal angles. We have 4 perpendicular lines, right? Well, 4 equal angles, 4 equal sides, 4 equal angles, that means that we definitely have 4 lines of symmetry. It's pretty much a rule for all of them. Every time you have a regular shape, which means you have equal sides and all equal angles, then you have that many lines of symmetry. So let's try it out. Here's our rectangle. Well, it does have 4 sides, but does it have 4 equal sides? No. So there's a different rule for this one. The top equals the bottom, and the left equals the right. So what we could say is we would say opposite sides are equal. Do we have 4 equal angles? That we do. We know that the 4 equal angles all equal 90 degrees exactly. They're all right angles. But a rectangle is special. How many lines of symmetry does a rectangle have? Not the same as a square. We've got a line of symmetry down the center, up and down, and we've got a line of symmetry from side to side. And that's it. So a rectangle has 2 LOS, 2 lines of symmetry. My square had 4 LOS. It had the same ones, the horizontal line, the vertical line, but then the square also had the diagonals. And that's how a square and a rectangle are so different. A square has 4 lines of symmetry, a rectangle has 2 lines of symmetry. Number 3. We're going to draw a picture of what we call a regular pentagon. And then next to it, I'm going to make just a different pentagon. Sometimes we call them irregular. If someone's talking about a regular pentagon is one of our pentagons. It has 5 equal sides. It has 5 equal angles. It has 5 lines of symmetry. So a regular pentagon, 5 equal sides, 5 equal angles, 5 lines of symmetry. Now, another pentagon would be just another 5-sided shape, but doesn't make this perfect pentagon we have over here. The one that you think of in your mind is the regular pentagon. This is what the Pentagon looks like in Washington, D.C. It looks like a regular pentagon. All right. Now, an irregular pentagon is any other shape that has 5 sides. So check this out. 1, 2, 3, 4, 5. Do you see how these bottom sides are much longer than the top sides? This is an irregular pentagon. Irregular pentagon means the sides are not all equal. So it does not have 5 equal sides. It does not have 5 equal. You would have to test out your irregular pentagon. There's not a rule. In this case, in this picture, we have one line of symmetry, but that would not always be the case. Next, we have a regular hexagon. A regular hexagon is one that's going to look perfect. It's going to have 6 equal sides, 6 equal angles, 6 lines of symmetry. It's almost perfect, right? That's pretty good. Down the middle, down the middle, down the middle, and then from vertex to vertex, or vertex to vertex, and vertex to vertex. So a regular hexagon has 6 equal sides, 6 equal angles, 6 lines of symmetry. An irregular hexagon would just be a 6-sided shape. 1, 2, 3, 4, 5, 6. Well, it's an odd looking shape, but it is a hexagon. 1, 2, 3, 4, 5, 6 sides. No lines of symmetry. So it does matter whether or not you have a regular shape or an irregular shape. Lastly, let's talk about 2 types of trapezoids. A trapezoid, similar to the one we drew yesterday, short line on the top, longer line on the bottom. We connect the sides. This side equals that side. This has a line of symmetry right down the center. It has 2 equal sides. These 2 are equal to each other. It also has some equal angles. I want you to look and see, do you see the acute angles? The tiny little cute little angles in this picture. Look at this one down here. This cute little angle would land on this cute little angle. And then this is an obtuse angle. It's a big angle. Would land on this big angle. So we have 2 obtuse angles, 2 acute angles, 2 equal sides, and even look, we have a set of parallel lines. Parallel lines never meet. All right, well, there's another type of trapezoid, and this one's called a right trapezoid. What do you suppose that a right trapezoid has? A right trapezoid has 1 right angle. Does that right trapezoid have any lines of symmetry? I see the right angle, it's right here. Or it could be down here. Look, we have 2 right angles. But does it have a line of symmetry? No. So we would say a right trapezoid has no lines of symmetry. All right. I want you to turn in your green book. We're in Module 4, page 91. You're going to see a whole bunch of shapes. And our goal is to identify the lines of symmetry in these shapes. So please turn to page 91 and get started on identifying your lines of symmetry. I'm going to start with my A. I know I could fold it down the center. I know if I folded it this way that the feet would end up in the air and they would not land on anything. So this one has 1 line of symmetry. My smiley face, 1 line of symmetry. My heart, 1 line of symmetry. Now H is special because look, I could split it this way and I could split it this way. So how many lines of symmetry does H have? 2, very good. Let's look at our butterfly. I turn it just a little bit more, it makes it easier to look at. If I split the butterfly right down the center, we would end up with a wing on both sides some body on both sides, some head on both sides, an antenna on both sides. So that does have a line of symmetry. Look at my hand. It doesn't have a line of symmetry because of my thumb. If I were to pretend to split it right here, my thumb would land up on nothing. This one has no lines of symmetry. Now, what about my star? I'm going to split it from the tip of the star down to the point right below it. It's one. I'm going to turn my star, and I'm going to go from the tip of the star to the point right below it again. That's two. I'm going to turn my star even more. I'm going to go from the tip of my star to the point right below it. Turn my star even more, from the tip of my star to the point right below it. And I'm going to turn it one last time to show from the tip of my star to the point right below it. So this is what we call a 5-pointed star. There are 6-pointed stars. There are lots of fancy stars. In this case, this is a 5-pointed star. And this star would have 5 lines of symmetry. 1, 2, 3, 4, 5. All right, keep practicing on your own. Take your time, do your best work today, and we will see you tomorrow.